Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Amira binti Zulkifli and we are from class RCDCS 1102C. My matrix number is 2023659458.
My name is Sharifah Sulaiman binti Abdurrahman. My matrix number is 2023684613.
My name is Batil Zara binti Umasha. My matrix number is 2023604342.
My name is Nisa Hasina binti Muhammad Saad. My matrix number 2023483176. And this is our group project for MAT183.
The title we choose is Application of Differentation Related Rates. This is our group members. Table of content. Introduction. What is related rates? Related rates are rates of change associated with two or more related quantities that are changing over time. These problems typically use the principles of calculus, specifically derivative, to establish a relationship between the rates at which different variables change. They are important tools for analyzing dynamic systems and understanding how variables interact in real-world scenarios. And now, why is it used? Related rates are used because they help us understand how different quantities change together over time. By using calculus, we can model real-world situations where multiple things are changing at once. This is important in fields like physics, engineering, and economics, where predicting how variables interact can solve problems and optimize processes. Next is problem statement.
So, this is our problem statement. If the radius of a ball is increasing at the rate of 8 cm per second, how fast is the volume changing when the surface area is 64 cm square? So, let's move to the next slide.
Next, problem solution.
So, this is our solution for our problem just now. We have dr per dt here that equals to 8. And we want to find dv per dt when the area is 64 cm squared. Here we have volume formula where V equal to 4 per 3 by R power of 3. And for formula area, we have A equal to 4 by R power of 2. So we're going to use these two formula in our solution. Okay, here we're going to use area formula to find R. So we have 4 by R power of 2 equals to 64. And then we're going to bring 4 pi to the right side. And we will divide 64 per 4 pi. We will get 16 per pi. And then we're also going to bring power of 2 to the right side like this. And we will get 16 per pi square root. After that, we're going to get R equals to 4 per pi square root. After we find our R value, we're going to differentiate our volume. So V equals to 4 per 3 by R power of 3. We're going to multiply 4 per 3 with power of 3. And then we get dV per dr equal to 4 by R power of 2.
After we get dV by dr and dr by dt, we can search for dV by dt. We put that into the equation. After that, we substitute r into the equation. After we substitute r into the equation, we will get 4 pi in bracket 4 over square root pi square times 8. For square, we get 16, square root pi square, we get pi. And then we times 4 with 16, 64, pi we will cancel each other. And then 64 times 8, we will get the answer, which is 512 cm cubed as negative 1.
And then the last one is conclusion. Related rates come in handy when we have two related quantities and one of their rates of change is much harder to find than the other one. And this is the references.
That's all for us. Bye! Bye! Thank you for listening.